Now, when I photographed this, I kind of made the mistake of going through and looking for the most linear, parallel strands of collagen I could to point out what tendons look like. This is white, fibrous connective tissue. But I sort of made a mistake in doing that. I don't want students to think that it all looks like this, so I included this one too. This is a kind of a more common view of white fibers. These nuclei are the fibrocytes, and then these long strands are the collagen fibers. Sometimes these tissues in the microscope look more like this. Yeah, they just have a wavier appearance. So this is what it looks like if you cut it through the edge. And what you can see here is the collagen and then the nuclei, the fibroblast nuclei. That's all you can see there. Adipose tissue doesn't really require a lot of discussion. It's really easy stuff to recognize. For the adipose tissue slides, don't bother looking at the brown adipose tissue. If you pick out an adipose tissue slide and it's stained with this osmium that makes them all look black, don't look at that either. This is the image I'm going to go for on the test. So this adipose tissue is all over the place. So I don't need to actually get a slide that says adipose tissue. What's this stuff down here? Yeah, very good. It's dense, irregular connective tissue. You might have been thinking, well, it could be smooth muscle, but you know, there's no smooth muscle associated with fat, is there really? So it has irregular connective tissue. And really, that's about all that's in there. The interesting thing about adipose tissue is there is a little bit of matrix in there between these cells, and that matrix is loose areolar connective tissue. So, you know, putting that in the connective tissue is just a way to categorize one of the anomalies. So let's skip that. Now we're looking at cartilage. Here are two layers of cartilage here. Now, what organ is this?
Trachea.
Raise your hand if you know what organ this is. Nobody?
Is it a trachea?
Raise your hand if you know what organ this is. Okay, yeah. This means I not really sure. It's the trachea.
Trachea.
And the way you know it's the trachea, if you couldn't tell by the cartilage, you could tell by the ciliated pseudostratified up there. So we have an epithelium, an underlying kind of denser live in, and then all the rest of this is the chondromucoprotein matrix. Elastic cartilage, two characteristics of elastic cartilage that are easily used to identify it. One is it has this really thick perichondrium. In both cases, whether you're looking at ear or epiglottis, it's going to have a really thick perichondrium, thicker than hyaline cartilage. And then the other one is all the stain for the elastin in the matrix. So that's pretty easy, right? So I could point to, what kind of tissue is this perichondrium? What does it look like? There you go. It's dense irregular connective tissue. So we have dense irregular connective tissue as perichondrium. We have elastin in the matrix. We have elastic cartilage and a little adipose tissue down there. And there's just a few little factoids that you have to remember. Here's the epiglottis here, and one of the characteristics of the elastic cartilage in the epiglottis is it's very fatty. And that makes sense. There's an advantage to that because the epiglottis is a trapdoor that goes over the hole of the trachea when you swallow. And this adipose tissue softens it up and makes it form-fit over the hole with no leakage around it. This would not work very good if it was the cartilage that held your ear in shape. Yeah, this is a more solid cartilage right there, but it's also elastic cartilage. I don't think I have a slide up here of the ear. This is a real close-up where you can see the individual elastin fibers. This is fibrocartilage, and this is a disc, so you can see they're short. But they are also striated, just like the skeletal muscle, because they use the same kind of contractile mechanism. Now, this isn't going to be one of the choices in the choice of 5. Cardiac muscle will be on its own, and I like the black stained cardiac muscle because the black stained cardiac muscle has the intercalated discs really visible. Now, in your slides, you may have seen the intercalated discs as white, right? If you notice that? Yeah. Some of them, some of the slides, they're like that. You know, they're white. Some of them are like two black lines with a little white in the middle. So that just comes from the staining technique. But this one here has really nice black stained intercalated discs. We'll talk a little bit about those when we talk about muscle physiology in the end of this course. Now, for the nerves, I have two slides out. There's a lot of different kinds of nerve tissue. There's actually 9 different types of nerve cells that you can identify. But for this go-round, what I wanted to include was just the neuron. But it's going to require 2 slides to see that neuron. So let me give you an idea of why that is. We've got markers up through this. They coil at the base, and then there's going to be kind of one tubule that will come up and exit out into the exterior. You can see the pigmented melanocyte layer there. You can see, which is actually part of the stratum stratum basale. You can see the nice stratum spinosum. You can see the granulation starting in the stratum granulosum, and then you can see the stratum corneum up very nicely up here. This does actually have a stratum lucidum, that little pink there, but very hard to see in this preparation. The papillary dermis is where these little finger-like things are sticking up. These are not little round things. So if you look at your fingerprints, they are caused by these papilla in the dermis, and they're not just little round things. They're long ridges that kind of move around at a point. Here's one that has a very nice stratum lucidum that you can see stained in different colors, so it really comes out. We have the epithelium, we have the papillary dermis, and then we have the reticular dermis below that. The reticular dermis is our best view of dense irregular connective tissue. This looks like smooth muscle to some extent, except there's less blood supply and less nuclei. And if you look really carefully at smooth muscle, you can see that this stuff that has that general appearance is more cellular. These are all sweat glands all over here. That's all sweat gland. There's a blood vessel right there. This is just another picture of the stratum lucidum there, so I'm going to skip over that. This is scalp, and one of the unique things about scalp is the stratum corneum, and it's got a really kind of wispy stratum corneum. If you ever cut yourself in the top of your head, you bleed profusely. And it takes a long time for the bleeding to stop, unlike any place else on your skin. But this doesn't show any hair follicles, but this is scalp here. Here's a hair follicle, and here's a hair follicle. So you want to make sure you can recognize these in complete longitudinal section and also in oblique and cross sections there. What I can see in here is a little bit of the dermis up there, but this is down all in the hypodermis. You can tell that because of all the adipose tissue. It's 2 hair follicles dipped way down into the hypodermis. Now this line right there is where the epidermis actually folds down the sebaceous glands associated with the hair follicles. For our purposes, sebaceous glands are stratified cuboidal epithelium. You can see that pretty clearly, and they are associated with hair follicles. These are the sweat glands down here, which are simple cuboidal epithelium. It is possible, if you get way down to the base of a sweat gland, to see at the very bottom of it, you might get a little stratified, but for the most part, they're simple cuboidal tubules. I think I have better pictures. Oh, here's Meissner's corpuscles. Meissner's corpuscles are only found in the dermal papilla, in the papillary dermis. They don't exist anywhere else. Here's a close-up of one. And all a Meissner's corpuscle is, if you dissected this thing out, you would find a modified neuron cell body with a little nucleus. They're correct, the hypodermis and the dermis, but a better answer would be at the junction or interface of the dermis and the hypodermis. You find them right where the two meet. So they're dermal in their derivative, but they dip down into the hypodermis to some extent. So all they are is they're just bigger versions of the Meissner's corpuscle, and because they have more collagen around them, it takes more mechanical pressure to trigger them. So these are responsible for, you know, really hard touch. You know, when you touch a solid object and you feel it, that's your Pacinian corpuscles triggering. And light touch is the Meissner's corpuscle.
Mice.
Now here you can see the Meissner's corpuscles would be up in these papilla up there, although this slide doesn't have any. And then down here, see, here's the end of the dermis, right? Right, it kind of goes through there.